The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everybody. Welcome to the webinar from Smart Vision, an introduction to the CRISP data mining methodology. Just before we get started, a little bit of housekeeping. This session will be recorded, so we will send you a link if you'd like to replay it or share it with colleagues. We'll also be sending copies of the slides, so we'll rather a link to the copies of the slides so that you can download these as well. If you'd like to arrange a more one-to-many rerun, then please just ask us. We can potentially do that on a kind of more specific, bespoke basis, and we can even look at some of your own specific business problems if we were to do that. If you do have questions during the session, lines are muted, so I can't actually hear you, but if you'd like to use the chat facility to just type your questions in, my colleague Rachel, who's producing behind the scenes, will try and answer as many of them as she can. If we run out of time to answer them, we'll certainly get back to you on email. Just a little bit about who Smart Vision are. Smart Vision are a partner of both IBM and SAS. So we predominantly work with the SPSS and SAS advanced analytic suites, data mining suites and statistical software tools. Between us, we have a frighteningly high average of over 20 years of experience working in what's now called data science, I guess, or what was called predictive analytics, and to some extent it still is. We all started off as statisticians and somehow find our way here. So just before I start to talk about CRISP itself, just looking at the list of attendees to today's event, we have attendees who come from different companies, and as usual, you probably will be looking at different types of analysis for data mining and data science and so on. We tend to, at the very top level, we tend to categorize the analytical types into three areas. The first area is really people analysis, which is very often customer, but isn't exclusively so. So increasingly, it's analysis of employees or students or citizens or other types of people analysis. The example I'm going to use today, just to sort of bring some life into the CRISP process as we step through it, is actually taken from a kind of customer analytic example. The second, and probably the most of the area that's growing the most at the moment, is what we tend to call operational analytics. So this is where, rather than analyzing people as the unit of analysis, we're analyzing machines and sensors and what's increasingly called the Internet of Things, though it isn't always that. So we're potentially looking to manage, maintain, and maximize uptime and productivity in operational environments. And the third and final area, which is one that's been around for a long time, but for various reasons is also growing, is the area of threat and fraud analytics. So this is where credit card fraud and what we might think of as more traditional fraud exists, but it's also where some of the more modern digital cyber fraud exists as well. In each of these areas, irrespective of whatever the analytical objective is, what we're typically looking to do is make predictions and find patterns, so use data mining potentially to find patterns and associations. So in order to do that, we ourselves tend to use and recommend the CRISP DM process. And today's webinar is really intended just to talk through in a little more detail what that process is and what each of the individual steps of that process are. So there are 6 steps, as you can see here. They start with business understanding and they end in deployment. And I'm going to talk about each of them in detail, but one of the reasons we do like the CRISP process model is that it isn't just about the business of preparing the data and doing the analysis. It is very much driven by research or business objectives to guide that data and analytical process. It's not the only process model, and we're not bold enough to say it's the one you have to use. There are others. Here's a survey that shows some of the other options that are out there from KD Nuggets. And if you haven't seen KD Nuggets website, I thoroughly recommend it. This was a poll, it's now 3 years old, so it's a little out of date, but the site itself has lots of resources, example data, links to solutions and software and so on, and lots of good papers and webinars in and of itself. So according to the last KD Nuggets poll, CRISP was the top process that was used. My own, interestingly, was the second, and again, you know, without wanting to be too dogmatic, I think as long as you have a process model that sort of captures the main ingredients of a data mining project, then that's good. It's good to have a structure, I think, to execute against. In third place is SEMA, which is actually from our partner SAS. That's more proprietary in the sense that it's actually designed by SAS, and it very much fits into the way that the SAS software works. Some of the SAS software actually has strong references to SEMA. So I'm going to go through the steps or the stages of the CRISP process in a little more detail. Before I do that, one of the points that we often make is that when you come to execute that process, it isn't just about the top right-hand corner here, the analyst or the analytical skill set or the analytical tool set, if you like. It does require a mix of skills or a mix of roles. On smaller projects, this may be 1 or 2 individuals covering each of these boxes. On larger projects, of course, we can have quite significant teams in each of these boxes. The purpose of each, or the role of each, analysis is pretty obvious, really. I guess it's the ability to understand how to apply the methodologies, what tools to use, how to interpret the outputs from the kind of often algorithmic analysis that we perform in data mining. Business is, of course, all about giving context to that analytical rigor. So understanding what the data means and what the business implications of it are, in a sense that providing a kind of an overarching direction to the whole project. Data, again, is somewhat self-evident in the sense that, you know, we need to be able to understand what the data means that we bring into the mix when we execute a CRISP DM process. We need to understand the structures. We need to understand down at quite a detailed level what the data means, how reliable it is, what the sources are, and so on and so forth. And very often, the top right and the bottom left are overlapping in the sense that the analyst, or increasingly as they're known today, the data scientist, does a lot of the data work and has to have a lot of the data understanding. But again, often on larger projects, data is kind of a role in itself, and you may have heard the term data engineer applied very much as a sort of counterpart of the data scientist. And then finally, technology. So this, in many senses, is really, you know, your own IT team, or in some cases, you know, IT that you know, you may partner with another company to get. And this is as data becomes more complex, as we work more in the area of big data and big data lakes and more complex data landscapes. We need a lot more technology to support that, but also we need technology in the final stage, which we'll talk about later, deployment, to actually put the results of analysis, which, for example, may be predictive models, into business processes. And often that requires some level of technical integration. It could require applications. It certainly requires usually some kind of technical wiring to get the models into the business. So this isn't, you know, one size fits all, but if we were to sort of map that into the 6 steps of the CRISP process, then when we come to do the first stage, which is the business understanding, which I'll drill into shortly, that's usually the business and analysis involved. Sometimes it's data, and sometimes it's all 4, and you can say that probably of each of these steps. But largely speaking, we're talking about the business and the data science people getting together and trying to sort of frame the problem and to understand whether the problem can be answered with data science and analytics. Stages 2 and 3, when we get into the data, as you might expect, involve the data science analyst and the data person, and that can, in some cases, as I mentioned earlier, be one and the same person or people. When it comes to the core running the analysis part, the modeling part as we call it, then typically that's the analyst, as you might expect. Evaluation is certainly the analyst. It's often, and I'll explain more about what evaluation is shortly, but it's often where the analysts and the business evaluate the outcomes of the analysis together to see whether what we produced is fit for purpose. And then finally, when it comes to deployment, well, it could be all of the above, really, depending on what the nature of the deployment actually is, and that's something that we're going to talk about in terms of what it might be. So let me start at the top then with business understanding, and what I'm going to do is I'm going to go through each of the 6 stages and give you a little more detail of what each stage is typically about and what we tend to do within each stage. There is a level of detail beneath this, and a lot of times when we use CRISP and others use CRISP, we tend to follow a fairly formal checklist of things that we need to do and outputs that we need to produce. In this webinar, I'm going to keep just sort of one level up from that, but certainly if you go to our site, you'll find a white paper and documentation that does go into that next level of detail. So within business understanding, the first thing that we're doing, as you might expect, this is really a kind of typical business discovery exercise, is we're trying to list and understand what the business wants to achieve and thinks can be achieved through data mining / data science. So on the customer side, we could be looking at things like reducing churn rates, acquiring new customers potentially that will go on to be valuable. We might want to cross-sell, upsell to them. On the threat and fraud side, we may be trying to prevent fraud happening. So can we identify fraudulent activity and stop it before it actually damages the business? The other thing that we crucially do here, and this is always an interesting discussion, negotiation often between the analyst and the business, is to define what good looks like. So in the context of churn, the business might say, actually, what we want to ultimately achieve is to reduce our churn rate by X%. It could be that we express the success criteria in terms of financial outcomes, KPIs. What the analyst then needs to do is to translate those those business objectives into analytical objectives. What does that actually mean in terms of, for example, model accuracy or lift or whatever analytical criteria that we're going to use? How do we achieve that from an analytical perspective? Often we're about understanding whether at this stage, this is very much planning at this stage, whether the whole effort is going to be worthwhile. So do we think there's going to be ROI there, or will there be enough ROI if we are successful? So if we make our business objective, and obviously it costs us a certain amount of money to get there, is it worth it? Does the cost benefit stand up? Importantly, and a lot of what I'm about to say I expect sounds like common sense, but we should be thinking about the final stage at the first stage. So we should be thinking about if and how we're going to deploy the results. And I know that sounds obvious, but you'll probably be surprised how many data mining efforts have failed at the last hurdle because we didn't think clearly enough about this particular question. And as I mentioned earlier, we typically end up documenting all of the above, really, and this is usually where we start to build the real project plan. We may have an idea in our mind, but this is where we really start to plan out what we're going to do next. So here are some simple, a selection of business objectives, all of which we've been involved in. And as you read down the list, you'll see that they cut across the 3 pillars that I talked about at the top of this discussion. So when we're talking about a water company wanting to reduce pollution, sometimes this is something called predictive maintenance, which I'm sure some of you have heard of, which is trying to predict when parts or components within an infrastructure will fail. So, for example, in the water utility world, this could be about pipes and the likelihood that pipes will fail. So that's very much an infrastructure things type of analysis. The second one is threat and fraud. The third one, it's about charity supporters, so it's not really customers in the commercial sense, but there are lots of parallels. and what we might want to do is increase supporter lifetime value. So these are the kinds of business objectives that we typically start with. There are often two ways in which you get going. Either the business objective is there and clear and everything falls from there, or you want to prove the value of, let's call it, data science to the business. So you may start off with a list of 3 or 4 different objectives, and we can work through the CRISP process to work out which is the best one to try and work with from the perspectives of the success criteria and the cost benefit that we talked about in the previous slide. So what I'm going to do as we go through each of the stages, I'm going to use a fairly simple worked example to just try and breathe a little bit of life into this discussion. The example I'm going to use is from the customer world. It is based on a real-life project that we were involved in. It's been heavily anonymized to the extent that the numbers are completely different and the field names have all changed. But what a particular retailer wanted to do, which retailer doesn't want to do this, was to increase revenue and profit. It's either that or reduce cost, or a combination of the two. And in order to do that, they wanted to increase lifetime value, and they had, and in this case, they were told, in actual fact, by a management consultancy that their repurchase rate was behind other competitors in their set, particularly their online repurchase rate. So what they wanted to do here, in order to drive those broader business objectives, was improve the repurchase rate. So the number of customers that don't just place a single transaction, or don't just make a single purchase and disappear, the one and dones as they're often called. But like most businesses, they have a cost constraint, so they can't try and incentivize all customers to buy twice, and that probably wouldn't make sense anyway. So what we set out to do here was to identify 40% of customers who will repurchase, but in the top 20% of all customers. So we wanted a model that would say, this 20% of customers, the top 20% of customers that the model says will repurchase, we actually have 40% of all the customers who ultimately do go on and repurchase. So those of you who've worked in this area before will recognize that's effectively a lift of 2. So analytically speaking, what our model will do is, what it will produce, and all predictive models do this, it will produce a score which is a propensity for a customer to repurchase, and it will also identify, I've got an error on my slide here that I'll fix before we send it to you. I should say identify the drivers of repurchase or single purchase. So what is it that we can tell about a customer on their first purchase, which tells us whether they're likely to buy a second time or a third time, and so on. And the business had a set of hypotheses. So in the business understanding phase, sometimes we'll do this, not always, but sometimes we'll sit down with the business owners and try and draw up a list of predictors, if you like, or drivers. What are those characteristics of a customer that tell us whether they'll buy a second time or not? Now, I'll come back to this when we talk about the way that we do the modeling, but it could be that we don't do this at all, that we let the data speak, which you might think of as more aligned with what we think of as data mining. We may have hundreds of potential predictors, maybe thousands in some cases. So should we do this where we come up with our list, or should we let the data speak? And I'll come back and talk about those two approaches later. Now, in the context of predictive analytics in CRM, and I think it's a good point to keep in mind that even if we're not looking at people or customers, if we're looking at machines, or if we're looking at fraud and threat, there's often a process at play. We can often think of what you might think of in this case as a customer journey, which has milestones across the journey. And the sort of classic, although it's quite simplistic, of course, CRM journey starts with attracting a customer to transact with you for the first time. Then there is the relationship bit, if you like, which is the main bit in the middle, where the customer is a customer of ours, he or she hasn't lapsed or churned, and what we want to do is enhance that relationship and potentially grow the profit at the same time. And then finally, we want to keep hold of that customer. We want to stop them churning, and we want to retain them for longer. So we're spending money at the beginning to try and attract the right people. We then obviously still continue to spend some money on them in terms of marketing and the whole sort of production side, and then we're trying to retain them to extend the lifetime value. So if you think of that from a churn perspective, where we're trying to retain them, what effectively happens, and this is how we kind of switch between the business planning into the analysis, we're going to look at what we know about customers up until a particular point in time once they've been customers with us for a while. And what we want to do, based upon what we know at this point in time, which is really this line here, what we want to do is predict what they will do next. So we're going to take all the data we have on them, which is historical data on a customer, and we're going to look at what they do next. Now, in order to do that, in order to build the model to do that, what we do is we move the lines back so that we can observe a period in time where we know what happened next. So did they churn or didn't they churn in this particular case? But that's the only piece of information we look at in that particular time window. In the earlier window, we use all the information we might have about them. So what channels do they use to make purchases? How many purchases have they made? What do we know about them as people? And so on and so forth. In our example, what we want to do is make a prediction earlier in the customer journey, because what we want to understand is how likely is it that a customer, after they made their first purchase, will make a second purchase or maybe a third purchase. So the downside of that is we probably know less about them. So this big box here of all the things we know about the customer at that point in time clearly doesn't have as much information in it as it would if we were looking at the first example where they've been with us for a longer time and we're trying to retain them. So that's the downside. And what we want to do is look at what happened in that first period. So in order to build a model to do this, what we need to have is historical evidence of what do we know about all these customers at a point in time, and then look at, let's say, 2 months or 3 months to see whether they went on to repurchase or not. So this is now we kind of know from a business and an analytical setup perspective what we're trying to achieve. Then we need to see whether the data will support that. And it doesn't always. More often than not, it does. And more often than not, you're kind of entering this process with a good insight into the fact that data is there to support this. But it doesn't always. And to some extent, the nice thing about CRISP, especially when we do something for the first time, is it gives us a series of go, no-goes. So it does allow us to make an evaluation of whether we're going to achieve our objectives before we go too far around the circle. So at a high level, what we're talking about is understanding data sources. And increasingly these days, we're bringing data together from different sources that hasn't been analyzed or correlated, which tends to be the term we use very often. The good news is that doesn't need to be a perfectly formed data warehouse in order to do this. In fact, it very rarely is. What we're really talking about here is bringing together data from different sources. Sometimes it is in one of the more contemporary big data, Hadoop, Spark, NoSQL formats, and that's great. We can work against that, and that's one of the ways in which we tend to bring a lot of this kind of data together. But very often we're mixing and matching between different formats. So really we're just trying to understand what's there, thinking about the business objectives and thinking about those hypotheses that we set up. And crucially, if we're going to make a prediction, and in data mining we're not always going to make a prediction, but very often we want to make sure that the target that we're trying to predict against is visible within the data. So that target field. And in our case, in our example, that's customers purchasing for a second time or not. So then, in the second part of data understanding, we start to do stuff with software. So the high level was really assessing the data landscape and what's available and what sources might be useful. The low level is starting to do stuff, maybe to test our hypotheses, certainly to start to look for the kinds of relationships that we hope exist that help us deploy and build models and change business decisions. So doing simple crosstabs and graphing and business intelligence style analysis, you might say, and to initially start to test our hypotheses. It's also about validating the data. So it may be that we're dealing with very clean data and we know it and we've used it for other purposes. Very often it isn't, and we maybe are combining data together that hasn't been analysed before. So it's important at this stage that we don't just dive in and start running algorithms against the data, that we actually look at the data to see whether it has any issues. And issues are usually things like gaps, missing values, unusual values, invalid values, and so on. So here are some examples. I'm just going to run them very quickly just to make this a little more real. I'm going to use the IBM SPSS modeler tool, which I'm not going to sort of talk about the functionality in more detail. I'll just illustrate how we do some of this stuff. So within modeler, and this is like a lot of data mining and data processing tools, you effectively build a visual data flow that's known as a stream. So my data here, and this is for our repurchase problem, is I've got about a historical view of about 225,000 customer records, and I've got various fields, columns here that describe each customer record and cover some of those hypotheses that we talked about earlier on in business understanding. So I've got things like, what was their first order channel? How many items did they order in that first order? What was the value of the order, etc. And then right at the end, I've got a view of that little window in my CRM journey, which says in that next 3-month period, how many of them went on to repurchase or not. So some of them are repurchasers and some of them are not. So I've actually got 2 fields here that sort of express that in different ways. So true or false, did they repeat purchase? So in terms of data understanding, I'm just going to zoom into this substream here that's called a supernode. I can do that in various ways. I could just run simple bar charts to say one of our hypotheses was that the first order channel is a strong determinant of whether a customer purchases a second time or not. So just doing a simple, effectively bar chart, customer bar chart in this example, or a crosstab, we can start to see whether any pattern exists. So this is a precursor to building models, but it does help sort of confirm some of our hypotheses and potentially help tell us what goes into a model. Excuse me. So we can see here there is pattern. So when customers came in on channel M or channel T, I mentioned this is anonymized data, they are much more likely to repurchase than those that came in on, for example, channel S or channel W. So we typically do a lot of that, visualize the data 2 by 2 in different ways, sort of one variable, 2 variables at a time, I should say. What we'd also probably do on the second part of data understanding is spend time just eyeballing the data and looking for data issues, so check the validity of the data. So within SPSS Modeler, there's something called the data audit node, which is set up to do exactly that. So it has lots of overview distributions and statistics that I can drill into if I start to think that any of these distributions doesn't look right for the field that I'm looking at. And it also has a kind of an audit table that tells me how many missing values do I have and what type of missing values do I have in each of those fields and how many unusual values do I have. And there's also, I'm not going to go into it at this stage, but there is an action option within this particular dialog that allows us to effectively do something about it. So that might be as simple as imputing values into missing values, or it might be as simple as excluding records that have a high proportion of missingness in them. So that's data understanding. Just going back to the slides. So you'll see in the slide deck I've got some examples of the kinds of outputs that we're talking about here. Then we're into data preparation, and I'm sure everybody on the call knows this, and you probably heard the same percentages quoted or similar percentages quoted before, but it's almost a cliche that when we do this for the first time, we haven't really used this data for this purpose before. Most of what we do through the whole CRISP cycle will be here. So we'll spend more time preparing data than we do anything else, analyzing it or maybe deploying it. Again, it's not always the case, but it's not unusual to find that is the case. So what we're often doing here is integrating data together. So we might be taking customer data, we might be blending that with sales data, we might be looking at customer service data. When you get into the Internet of Things, there are lots of different sources that might be blended together, geographic, sensor data, and so and we might be computing new fields. Now, data preparation is called many things. In the IT world, it's called ETL, extract, transform, load, and often what we design here as we're building models and working out what the right data structures are for those models, when it's deployed, goes back into a proper systematic ETL process. Data preparation is also known as data blending, data munging, data wrangling. So whenever you see these terms, and you may use them yourselves, really we're talking about pretty much the same thing. So an example, I won't run this live in the model stream. I'll come back to the stream in a minute when we actually run some models. But a really simple example might be that one of our hypotheses of drivers of repurchase, predictors of repurchase, was which day of the week was the first purchase made. Now, in the data as we had it, we had a data purchase, but we didn't actually have a day of week. So within Modeler and SAS and any of the data mining tools, you can apply formulas and functions just as you can in Excel or SQL. So we can actually get a new field or create a new field that contains that value 1 to 7, which tells us which day of the week did they make that first purchase. With all the hard work done, actually that's not true, because deployment can come back and give us challenges as well. We'll talk about that shortly. But at least now we've done some hard work, and we've probably earned the right to do what we often think of as the more enjoyable piece of the process, which is to build some models to see how well we can match the success criteria that we defined back in business understanding. And that evaluation of how well we match the criteria is what evaluation is. So steps 4 and 5, they're distinct, but they're very closely coupled. So typically we're running analyses, we're building models, we're testing algorithms, and we're seeing how well they perform. So is one algorithm better than another algorithm in terms of addressing the success criteria that we set out for ourselves? So when we're running models, this is back to something we discussed earlier. It can be bewildering if you're entering the world of algorithms. I realize that some of you may already be there, of course, but there are lots of algorithms. It's almost like the algorithms are not the issue anymore. You know, there are plenty of open source algorithms out there, lots of machine learning libraries and so on. The type of algorithm you use is really driven by the type of the problem and the type of data that you have to start with. So that narrows down the number of algorithms that you might actually use to perform the modeling. And then we're into the question of which fields or variables do we actually feed into the algorithm as predictors or as the sets that we want to use for mining, maybe for association or segmentation or something. So there are two approaches. The hypothesis-led one is actually where we went with this project, as I mentioned. So we came up with our list of 10. And that's great, because that's usually driven by the business and business understanding and experience, and very often that's going to give you a good model. The danger with that, of course, is that you might miss something, because we don't know everything. And it might be that if we just let the algorithm look at more data, so we take a more data-led approach, then we might build a better model. We might find better predictions. So that's more data-led. There's no right or wrong in this. I think in our experience, it's good to think and try both approaches. The downside of the second one often is if you start with a very long list of variables, then it's quite difficult to interpret the models. There's a lot of obfuscation. You often end up finding you get results that don't always make sense, and you need to actually whittle down the fields that are going into the model. But if you think of that, both approaches, and you shouldn't necessarily do one above the other. So one of the important points about running the models, so this is part of the stream that I'll just go back to in a second, and this in some ways is kind of the secret sauce if we're going to do prediction, is we need to make sure that the model performs well on data that it doesn't see. So we use, in the SPSS world, it's all about sampling, but we use a particular node called partition that will take a random sample, sometimes 80-20, sometimes 70-30, it depends. It will take 70% of our customers and build a model on them, and it will test that model on the 30% of customers that it didn't see if we use a 70-30 split. We then have something called the type node, which allows us to specify the model. So in this case, we don't actually have that many fields. It's quite a simple example. You often have more than this. You could have tens, hundreds, thousands even. And you need to tell the model what are the candidate predictors. So that's what all the the fields that are flagged as inputs are. You'll see some of them are turned off. We set them as none. We need to tell the model what the target is for the prediction. So what is it we're trying to predict? And of course, in our example, it's repeat purchase. And in some cases, we very often experiment here. We may turn things on and off. In evaluation, this is where we use that partition that we created to see how well the models perform, how accurate are they, and there are different ways of measuring accuracy, which we can sort of talk about in more detail. And usually, in business understanding, we agree not only the if you like the business objective in terms of pounds, shillings, and pence, or percentage of customers who repurchase, or KPIs, but also how are we going to assess how good the model is in an analytical sense? Is it about overall accuracy? Is it about lift? Is it about gain, and that kind of thing? So we're very much evaluating against the success criteria. So here's one of our models. I'm just going to flip back to IBM SPSS Modeler so that you can see this. So here we ran, and if I show you in the modeling palette down here, you'll see these are some of the algorithms that this particular tool has. As I said, there are just hundreds of algorithms available to us to do this kind of work now. So basically, we run an algorithm, and here I ran a shade algorithm, and I ran a C5 algorithm, and the C5 algorithm, if I just look at that first, tells me the detail of the model itself. It thinks that first order day of week, the field that we created, is the most predictive, followed by delivery type, followed by the number of order items, and so on and so forth. Then we've got a shade algorithm that agreed to some extent, first order day of week, but then the second most predictive thing was first order month. So a strong evidence of seasonality as far as the shade model sees it. And we can run them head to head. We can say, well, which one was the most accurate? And one way to assess that would be to run both of them through a gains curve. I think I've done here. I'll find out in a second. Yes, a gains curve. So what this is saying, the green line is the shade model, and the blue line is the C5. And you'll see that the C5 is just slightly better than the shade model in terms of its gain. Let me explain what this chart actually means. So on the left-hand side is the performance of the model on the 70% training sample. On the right-hand side, it's the performance of the model on the 30% test sample. So the data, the 30% of customers that the model didn't see. So this is the better test, because this is more like what we'll do when we actually put the model into action, when we deploy it. And remember, we said in our top 20%, what we want to do is identify at least 40% of customers who go on and repurchase. And that's what this number is on the y-axis. So in the top 20%, the shade model is identifying 56% of customers who go on and repurchase. And the C5 model is identifying 64% if we round it up. So usually in the modeling and evaluation step of the CRISP process, we're doing a lot of that. We wouldn't just test two models, we'd probably test more. There are various automated ways of testing multiple models at the same time. We wouldn't just look at the accuracy, we'd also look at the detail of the model. So what is the insight, if any, that we're getting from the model? And what are the rules that are coming out of the model? So I'm not going to go into great detail of it, but this is effectively the set of rules that the model is using to make that prediction. So we've spent some time reviewing that. There may be insight in that. There may be things in that that we don't like that we need to change. So modeling and evaluation is very much an iterative process. Generally speaking, if we're not hitting our success criteria, we may try different algorithms, but often the best answer to improve a model is to go back and get more or better data. So finally, last but not least, the proof of any pudding, of course, is in the eating, is that we need to deploy the model that we create. Sometimes that's very simple. Remember, when we're building a predictive model, we come out with a set of scores. So maybe we just put that set of customer names, customer ID, and scores into an Excel file, into a list, and we send it somewhere. We send it to our marketing team, we send it to an agency. We send it to our call center. We send it to our field technicians. You know, we just send it as a file. On the other end of the scale, deployment can be very technical. So this is where IT tech needs to get more involved. It can be as complex as a model encapsulated in an operational system operating in real time. So sitting behind the call center, potentially scoring customers as they come in with their propensity to repurchase or to defraud or to churn or whatever it might be. Whenever we've got models, we can do simulations around them, so we can experiment with different scenarios and values and see, well, what would happen if we increased spending on advertising? What would happen if we had more call center staff in the call center and so on? So in our repurchase example, when we modeled the data, we were just working with historical data. So we said, let's look at everything we know about a customer just after their first purchase, and let's see which of them then go on to make a second purchase or not. When we take that model and roll it forward, then we know the first bit, but not the second bit. So we're actually saying at that point in time, we're going to score customers. So this might be today. We're going to score customers using the winning model, and that model will then make the predictions about what happens next. So in our example, and I'll use Modeler again to just help visualize this, our C5 model was the best model. So we can take this. There are different ways in which we get the models into other things to deploy them. We can export them out as SQL, PMML. There are a whole set of things that we might do. We might just recode them into something. But here what I'm going to do is I'm going to take that model into a new stream, which is effectively my deployment stream. And this has 2,240 customers who just purchased from us the first time. So what we're asking the model is, amongst these customers where we have the same data on them that we had when we built the model, which of them are going to go on and repurchase or not? And you'll see, of course, because they're new customers, we don't know at this stage. So that's what the model's here to do. So if we wire the model into the same process, just run it through, then, oops, sorry, I turned off the actual prediction. Let me turn the propensity score on, because that's quite an important part of the process. So I'm just going to turn that back on, and that's that thing there. So I'm just going to say, I'll just call it score. I'll probably call it propensity score, and I'm going to sort on score. I called it propensity to repurchase when I first did this. I'm feeling lazy now, so I'm just going to run that again, and you can see the top customer, according to the model, is 100% certain to repurchase. But the scores go from 0 to 1. We often multiply them by 100 just so we got a kind of more intuitive number. There's a whole set of customers here who are 92% likely to repurchase, and then on down the list until we get some halfway down now. We're down to 40% likely to repurchase, and eventually we get down to a very low 2%. So that's one way in which we might deploy, and that, that might just be a score that we send to a file. Or this particular mini job, if you like, could also be the thing that sits behind our website, and every time a customer comes to the website, makes a purchase, we collect those fields, run the data through the stream, out comes the prediction. It's important, just to finish off on the CRIS process, it's important, it's inevitable that no model lives forever. Depending on the context into which we deploy the model, some models will last for a year, some models will last for a day. It really just depends on essentially the volatility of the market and the scenarios into which we deploy the model. So we have to keep monitoring the model, see how accurate the model is as the days and weeks go by, and we have to think about replacing a model that starts to become less accurate. We might assume the model will be as accurate as it was when we evaluated it in that sort of last but one stage of the CRIS process, and then as time goes on, that accuracy will diminish. You'll hear, I'm not going to talk about it in any great detail, but you will hear of some automated ways of doing this. You can have self-adapting models. There's something called Champion Challenger, where effectively you have a bench of models, and at any point a Challenger model can replace what was a previous Champion model because it's just more accurate, and that can be done in an automated fashion. So that's the whole process. As you might expect, we sort of paint it as a sort of linear cycle. In reality, we dot around for various reasons. Modeling and evaluation is fundamentally cyclic in itself. But very often we find things in modeling that take us back to data understanding. We have to potentially fix data or find new data and so on. One of the benefits of CRISP, which I don't think I said at the beginning, or one of the positives, I guess, is that it wasn't designed by a single vendor or a single consultancy and so on. So it was designed by a consortia of academics and commercial and technology people. IBM have fairly recently developed an extension to CRISP that they call ASIM-DM. So on the right-hand side, the labels are slightly different. We're talking data wrangling now rather than data preparation, because that's a more modern term. But it starts with CRISP or its own cycle. And I think that's right. I think we've been saying for some time that deployment is growing of its own. So we're very much warm to the whole ASIM-DM adaptation of CRISP. And another thing that it does very well, which I didn't mention particularly when I was talking about deployment, is it's not always about integrating a model into an operational process, which is really what this particular part of the cycle is. Often it's about using insights. So, we might find that there's a particular problem with a particular store or a particular base station on our mobile network. We don't necessarily have to plug a model in to fix it. We might actually just have to send somebody out to do that. So sometimes embedding insights and changing the business as a result of data mining isn't about integrating models in a technical sense. I did intend to put a link to ASIM-DM on here, which I'll do before we send you the slides. Final points from me. I'm just running a couple of minutes over our sort of scheduled time. A predictive data mining project, and I didn't use the term, but I think it's a good one to have in mind, is often like a piece of research and development, especially if you're building models that haven't been built within your business before. We don't know necessarily that it's going to succeed, so we are testing our own hypotheses about whether or not it's possible. So part of what CRISP is good for is helping us, especially through the early business understanding phases, measure and potentially mitigate the risk of not being able to meet those objectives. I don't want to paint glass half empty, because more often than not we do meet the objectives, and largely because we do have some control over what it is we go and analyze if we go and do it, and that's some of the flexibility that CRISP gives us. Other key points I'd say, it's not just about data scientists or analysts. The mistake that we made in the early stages of data mining was to say to the analysts, here's some data, go and mine it and tell us something. And that rarely works. It can work, but usually you require that, certainly the business input, that real understanding of the data and the other roles that we talked about earlier on to make a project really successful. There is more detail and a white paper that you can download from our website, so we'll include that link in these slides. And then a final couple of slides just about how you might work with us. I hope you found this session useful. Part of what we do are sort of educational webinars and seminars, and if you go to our site, you'll see where some of these are available, some of our other webinars and so on. But our primary purpose in life is to resell SaaS and SPSS and increasingly other types of software. We also work a lot more with open source these days. So we're very happy to talk about projects very much from an enabling angle. We're not really an outsourced provider of analytical skills. What we prefer to do is work with your teams on real projects and get you up and moving. And the final thing, just very specifically, we're running a training course on the 15th or 16th of June, which is an introduction to SPSS statistics. We will be running more courses on Modeler and other tools and software as well. If you're interested in that, again, there's a link in the slides here that we'll send over to you, and there is an offer code for those of you who've attended this webinar today. So finally, from me, just Thank you. I realise it's Friday afternoon, and we very much appreciate you taking the time to join us so late on a bank holiday weekend as well. So we hope you found it useful. If you had questions and they weren't answered, then I assure you we'll get back to you, and we will also email all the various links that we talked about. But if you've got any follow-ups that you didn't manage to get answered, then do please get in touch with us, and we'd be delighted to talk to you. Thank you very much.